All right, we have your tan integral. This one's from Caltech Math Meet 2024, number 4. And for this one, I think we just have an obvious u substitution. We don't really like having 1 over x in the exponent right here. So let's just try, let me do my u substitution just for this. So we'll set u equal to 1 over x. Now if I take a derivative, our du value is just going to be minus 1 over x squared dx. That's going to work nice with our x squared right here. What I can do, imagine kind of a phantom 1 over there. So we have the 1 over x squared, and we can kind of just create like a minus sign so we can match this exactly with this part to the right. But so I don't change it, let's just multiply by minus right there. So now we'll do the substitution on this. First, we'll plug in infinity here. That's going to be going, if we plug infinity into the denominator, that's going to 0. You plug a 1 in here, that's just going to be a 1. And then just like that, the whole integral is just going to simplify down. It's just going to be e to the u, and everything else over here is du. So we just have e to the u du. I'll take the minus sign. We'll just use that to flip the bounds around. So now, whoops. So now we're going from 0 to 1. Go ahead and integrate. I'm almost concerned that I'm not using enough of the board. So we integrate here, we're going to have e to the u from 0 to 1. Plug in order to finish it, and what we're left with for the final solution on this is just going to be e minus e to the 0, which is just 1, and that's it. Okay, that's almost too easy, so let's just try to let's do 2 problems in one video. I've got paper here, so we'll pick another one. I think let's try number 3. Okay, for number 3, this one is also an easy one because this thing is a really common identity. 1 plus tan squared x is going to be the same thing as secant squared x. But what I can do is take this, we can bring it into the numerator, and when we do that, it becomes cosine squared x. What that's going to allow me to do is let's write everything in terms of sines and cosines. So how it's going to look, we'll have pi over 4, 0. Then 2 tan x in terms of sines and cosines is going to be sine x over cosine x. All this stuff became cosine squared x dx. But then I can cancel one of these with one of these. But then what we have left here, 2 sine x cos x, that's the same thing as our double angle formula. That's going to be the same thing as just sine of 2x. So that's going to allow me to just go ahead and integrate this thing. Integral of sine is going to be minus cosine 2x, but we need a 2 to pop out right there, so we'll get a 2. And the denominator, we just need to evaluate from 0 to pi over 4. So now evaluating at pi over 4, when you plug it in here, that's going to be cosine of pi over 2. Cosine of pi over 2 is 0, so that's going to be our first part here. Then next, minus, just we have to keep track, we don't want to, but we still have this minus in front here. You plug 0 in, you're going to have cosine of 0, which is just 1. So we're going to have minus 1/2. Minus times minus is plus, and so for my final solution on it, we just get 1 over 2, and that's it. All right, there you go. 2 easy problems from Caltech Math Meet 2024. Thanks everyone for watching. Have a good day.